Hey, this may not look like much right now. What you see here is a dashboard reporting the temperature in almost real time. The data comes from weatherstack.com that provides weather data for a particular location of your choosing. For this setup, I have a Python script that retrieves this data, and it runs on a scheduler set by Airflow, and it inserts the records into a Postgres database. The architecture looks like this, where live data gets extracted by Python and transformed using dbt and loaded into Postgres. This is all automated using Airflow, and the data is visualized using Superset. Now, the other feature of this project is that everything runs inside Docker containers, which means that all of these tools are running on an external server and none of it is installed into my computer. If you stumbled across this video, this is just the first version, and I do plan to make improvements to the tutorial and explanations. But if you're just starting out on your data journey, I hope I can give you at least a little bit of exposure to all the various things within this ecosystem. And if you're more experienced with some of the tools that I'll be demonstrating here, then I am looking for and will appreciate any feedback that you have, since everything here is still in the development phase, and I do want to make this production ready. So without further ado, let's get started. Let's search for Visual Studio Code, and I'm going to click on the first link. Then I'm going to download for Windows. The download has started, and let's open the exe file. I accept. Next. I'm going to install it into my Programs folder. I'm going to create a program shortcut in the Start menu. I don't need a desktop icon. I don't need these. I'm okay with these two. Next, and install. And let's finish. And now we have Visual Studio Code. I'm going to check a few things. I'm going to go to Open a Remote Window on the bottom left, click on WSL, and it should have installed the extension. So I'm going to click on Extensions, and let's see what version we have. We have 0.99, which is the latest. Let's go to the bottom left again, open a remote window, and connect to WSL using distro. It says no WSL distros found. Let's go to the bottom left again, open a remote window. Let's click on Connect to WSL. And here we should see a button, Add Distro. I'm going to click on that. And I want to install Ubuntu version 24. Click on that. Let's give it a few minutes. Now, since I'm creating a new instance of Linux in my computer, it's going to ask me to create a username and password. So my username is going to be Calvin, and I'm going to create a password and retype the new password. And I am now inside my Linux instance. Let me clear the terminal. Now I can exit out of this Linux instance by typing exit, and now you can see that my location has changed to my local system. I can log back into my Linux instance by going to open a remote window, clicking on Connect to WSL using distro, and then clicking on the instance that we just created. Now look at the bottom left. We are now remote connected to our Linux instance. Let's go into Explorer, open folder, and you see that we're currently in our user folder within the Linux instance. Click OK. Do I trust the authors? Yes. Now these are the files in our user directory. You can imagine we're starting with a blank desktop. So I can open a new terminal. This tilde means that I'm currently in the user directory right here. I can go ahead and make a new folder. I'm going to call it repos. And this is where I'm going to host all of my projects. You could see it right here. Or I could use VSC to click and create a file or a folder and just name it right here. You can also access this directory through your file explorer by searching for //WSL $/, and that's going to take you to the Linux instance. And you can see in home, you have your user file, which has all the content that we see here. Let's exit out of this, and let's finish setting up our Linux instance. We want to make sure all of the packages inside of this instance is up to date. So I'm going to do sudo apt update, enter. I'm going to type my password. And then I want to upgrade some packages. So I'm going to do sudo apt full minus upgrade. Enter. I'm going to hit Y to continue, enter, and let's give it a minute or two to finish upgrading. Now the upgrade is complete. I'm going to clear this terminal, and I'm going to check for a few things. Python 3 -- version. I see that Python came already installed with Ubuntu, and I'm going to check pip -- version, and I see that pip does not exist, so I have to install that. Pip is a Python installer package, and it's going to help me install any Python libraries that I'll need for my projects. I'm going to do sudo apt install python 3 - pip, enter, yes to continue. Let's give it a minute or two. Now I'm going to check pip -- version, and I see that it's been successfully installed. So that finishes setting up my Linux instance. This is docker.com, and I'm going to download the Docker desktop for Windows AMD 64. Docker is kind of like the app store for many popular tools that are used in software development. Let's open the exe file, click yes, and I don't need a shortcut, okay. Let's give it a minute or two, and now I have Docker installed on my Windows. If I open Docker, it's going to take me here. I hit accept. I already created an account, so I can log in with my Gmail. I'm going to skip the survey. And you probably noticed on my screen as it was installing, it's created some backend folders in my Linux instance because Docker on my Windows can actually communicate with my Linux instance. And you could check by going into settings, resources, WSL integration, and you see that it's detected our instance, so I can enable the integration by toggling the switch, apply and restart. I can X out of this, and I can X out of this. So now I have Docker set up. This is weatherstack.com. This is where we're going to get real-time weather data. If we look at the pricing, we will see that with the free plan, we can make 100 requests a month. Unlike the other paid plans, we do not get full historical data, and we can only request weather data for one location. If we go into documentation, we can see what the API request should look like. And if we keep scrolling down, then we can see the structure of our response. We have things like the name of the location, the local time, we have the weather description, we also have the temperature, and the humidity. So let's go ahead and sign up for a free account. We're going to select the free plan, fill in your details here, and click on sign up. Then when you log in, you get your API access key. And you could see I've already made 59 calls this month. Okay, I'm going to go ahead and clear my terminal, and let's set up my project folder. I want to call this Weather Data Project, and inside this folder, I'm going to create another one called API Request. Now I'm going to make a Python file called API_request.py, and here I'm going to create a function that will let me fetch data from the API URL. So let's say def fetch data, and I'm going to do requests.get API URL, and the output of this I'm going to save as response, and then I'm going to print the response. Now I need two things here. One is I need the request library for this line to work, and the second is I need the API URL. So in my terminal, let me see if I have the request library. I'm going to do pip show requests, and it is available. So up here, I'm going to import requests. And the second thing is I need my API URL. So I'm going to go into Weatherstack, and I'm going to copy the example API request. I'm going to wrap this in quotes because it's a string, and I'm going to squish this because it's a URL, just like that. Going back to my dashboard in Weatherstack, I'm going to copy my API access key and paste it right there. And then finally, let's call the fetch data function. I'm going to save this. I'm going to cd into the API request folder. So let's see where I am right now. If I do ls, then I can list all the content of my current directory, and I can cd into repos, then cd into weather data project, and then API request. Now I'm going to do Python 3 API underscore request.py to run this file, and I get a response of 200, which is successful. At the end of response, I'm going to do .json parentheses so that I can parse through this JSON, save, and run the file again. And now we could see the contents of this response JSON. So let's finalize this function. I want to implement a try except block so that I could be notified of the status, whether it was successful or not. Under the response, I'm going to do .raiseForStatus, which is a method of the request library that raises an exception for 400 or 500 HTTP errors. Ultimately, it is the response.json that I want as the output of this function. So this is what I'm going to return, and then I'm going to print API response received successfully if it does pass this check. And for the accept, I'm going to do request.exceptions.requestExceptions, or singular, as E, where I'm going to re-raise the exception, and I'm also going to log as an F string an error occurred, and the variable E. I'm going to clean up the formatting, and I could also clean up the API URL by creating a variable API key, turning the URL into an F string, cutting out the key, Control X, inserting the variable API key right there, and then pasting my API key up here. Save, and if I run the file again, then I get API response received successfully. As an afterthought, maybe right before the try block, it'd be a good idea to say something like fetching weather data from Weatherstack API, just so that we know that we've started running this function. And I'm going to save this. And since I know that I'll be using the output of this function, I'm just going to create something like mock fetch data and return this object so that we can simulate getting a successful response without making additional API calls. So I'm going to comment this out for now. Hey, it's me from the future. You don't need to comment this out. You could just leave the two functions and delete this call, just like that. And now I'm just going to clear this terminal. Inside the API request folder, I'm going to make another file and call it insertRecords.py. And I want to see how I can access this function in the API request file from this new insert records file. I can do from API request, which is this file, import the mock fetch data function like that, and then I can call the mock fetch data function like this. And then I can print the results of this function, save, and I can cd into the API request folder, which I'm in, and I can do Python 3, insert records.py, enter, and now I have data from another Python file. And this idea of importing functions from other Python files is really going to help me out with organizing this project. Now let's talk about how to save this record in a database. The database we're going to use is Postgres, and I'm going to create a new file under the project folder and call this docker compose.yaml. And this file is going to contain code that will allow us to access and configure the apps that we need. So I'm going to start with services, and the first service I'm going to call is DB. And I'm going to call this service container with container name as Postgres container. Now I need the image for this service. Let's go to Docker Desktop, and if the icon's unresponsive, I can go to Task Manager and look for com.docker.backend, right-click and end task. And I'm also going to look for Docker Desktop. I'm going to right-click and end task. Now let's click on Docker Desktop again, and now it opens up. So I'm going to search for the image, Postgres, and here I have the image name, and here I have the tag, or the version. I see that the latest version is 14.17, so in Docker Compose, I'm going to write Postgres:14.17. Now for the ports, I want my local Linux system to communicate with Postgres, which lives inside the Docker server. So I'm going to bind the local port 5000 to Docker ports 5432, which is what Postgres uses. And the convention is usually to match the port numbers, but I'm just using 5000 to help us see patterns later on. Now I'm going to overwrite some variables that Postgres has. So I set up the environment, and those variables are Postgres DB, Postgres user, and Postgres password. For Postgres DB, I want my database to be called DB, and for user and password, I can use whatever credentials I want. So DB user and DB password. Now I want Postgres to save its files and tables to my local system. So I'm going to set my volumes, and I want Docker to create this folder in my local, which is going to be inside the project folder, Postgres data. And I want Docker to mount it as its own var lib PostgreSQL data. Now let's save this. I'm going to open a new terminal, and I'm going to run docker compose up. And you could see that the Postgres image was pulled, and our database was created, and the initialization process is complete. Now I'm going to open a new terminal. I'm going to cd into the project folder, and I'm going to run docker compose execute, and I'm going to execute the service db, and within the service I can use the Postgres command psql -u for the user and -d for the database we want to access. Now at this stage, you might get Docker permission denied, and this is because group memberships don't carry over to a new terminal session unless we log out. So in that case, you can refresh your group membership for this new session with new group Docker, and then you should be able to execute Postgres. So now inside Postgres, if I do /l, then this is a list of all the databases that I have in Postgres, and we see the one that we just made, DB. If I do /dn, then this is a list of all the schemas or datasets that exist inside of the DB database. What if I wanted to check the other database? I could do /c with the name of the database I want to access. So let's do Postgres. And then here, if I do /dn, then now I have the schemas or the datasets within the database named Postgres. So let me return back to the DB database. And then if I do /dt and then public.star, then this should list all the tables that exist within the public schema, but right now we don't have any tables. Okay, so let's open a new terminal and go to insert records so that we can start creating functions to save data from the API request into our database. Let's remove this line. And the first thing we're going to do is create a function called connect to DB. I'm going to print connecting to the PostgreSQL database, and I'm going to set up my try and except block. Now, how do we connect to Postgres? We're going to use a library called psychopg2. Let me see if this is available. I'm going to do pip show psychopg2, and it says package not found. So we're going to install this by doing pip install psychopg2 -binary. And we get an error that essentially says, do we want to install this package for our whole system, or do we just want to install it for our project? And I just want to install it for my project. So I want to create a virtual environment, which is an isolated folder where you can install a bunch of packages that will be confined only within your project. So I want to cd into the project folder, and this is where I want to create the virtual environment. So I'm going to do python3 -m venv, and then the name of my virtual environment folder, which I just want to call .venv. It says the virtual environment was not created because I don't have this package. So I'm going to do sudo apt install python 3.12 -venv. I'm going to enter my password. And now let's try to create the virtual environment. Here's my virtual environment folder, and we can activate it by doing source.venv. And if we open this folder, we have bin and the activate file. So bin activate enter, and this means that we have it activated. So inside the virtual environment, I can go ahead and pip install psychopg2 -binary. And then if I do pip show psychopg2, or let's do psychopg2 -binary, then we see that it's been installed. So back to the insert records file, I'm going to import psychopg2, and then in the try block, it has a method called connect, and it's going to connect with the following parameters. Host is localhost, port is 5000, DB name is DB, user is DB user, and password is DB password. And these are values that we determined in the Docker compose file. The output of this, I'm going to save as con for connection, and I'm going to print con. In the accept block, I'm going to use psychopg2's error as E, and then print as an F string, database connection failed, and pass the E variable, and then raise the error. I'm going to call this function, save this, let cd into the API request folder, and run this file with Python 3 insert records.py, and here we have the connection object. So this is what I want to return as an output of this function, so I'm going to change this print to return. Now the next thing we have to do is create a table. So let me remove this line, and I'm going to create a function called createTable, and this is going to depend on the input con, which is our connection object from the previous function. I'm going to print creating table if not exist. Then I'm going to set up my try and accept block, and in the try block I'm going to use con, which has a method called cursor, which allows us to do things inside Postgres. I'm just going to initialize this as cursor, and then I'm going to use cursor to execute some SQL. Here's my triple double quotations up here and down here, and then I'm going to do create schema if not exists, dev semicolon, and inside dev I'm going to create a table to store data from the API request. So I'm going to do create table if not exists, dev.raw weather data. Now inside parentheses I'm going to create the column definitions. So I want ID, which is going to be the serial and the primary key. I want city as text, the temperature as float, the weather descriptions as text, the wind speed as float, the time as timestamp, the inserted at as timestamp to default as now, and the UTC offset as text. I'm going to add a semicolon at the end of the parentheses, and then after execute, I'm going to do con.commit. Then I want to print table was created. In the accept block, I'm going to use psychopg2's error as E, and print as an F string failed to create table, and pass the E variable, and raise the error. Let's test this out by calling the connect2db function, saving the output as con, and then calling the createTable function with con as the input. Let's save this. I'm going to run this file, enter, and it says table was created. Let's go back to the Postgres terminal. Let's do /dn to see that the dev schema was created, and then /dt dev.star to see that the raw weather data table was created. And now I could do select star from dev.rawweatherdata semicolon to see that the table structure was created. Now obviously there's no records yet, but now we're going to insert the record. Now I'm going to create a function called insert records, and the input's going to be the connection object and data which I get from the API request. So first I'm going to print inserting weather data into the database. I'm going to set up my try and accept block. In my try block, I'm going to use the connection object and initialize the cursor just like we did before so that we could do cursor.execute some SQL. Here's my triple quotations, and my SQL is going to be insert into dev.rawweatherdata, and in parentheses, I'm going to list all the columns, so city, temperature, weather descriptions, wind speed, time, inserted at, and UTC offset. I don't need the ID because this is auto-generated by Postgres. And at the end of the parentheses, I'm going to insert the values, which come from the source for city, temperature, weather descriptions, wind speed, time. The value for inserted at is going to be now, and UTC offset is going to come from the source. Now the SQL is only the first input to this execute function. The second one is going to be inside parentheses, the location of these values. So the city is going to come from data, location, name, and the temperature is going to come from data, current, temperature. But looking at the Weatherstack documentation, it seems like everything we need is going to be in location and current. So to clean this up, I'm going to set data current as weather, and I'm going to set data location as location. That way, I can replace this with location, and I could replace this with weather. The weather description is going to come from weather descriptions and the 0 index. The wind speed is going to come from weather wind speed. The time is going to come from location local time. And then the UTC offset is going to come from location UTC offset. After the SQL, I'm going to do con.commit, and then I'm going to print data successfully inserted. In the except block, I'm going to use psychopg2's error as E, and I'm going to print as an F string, error inserting data into the database, and pass the E variable, and then I'm going to raise the error. Now let's test this out by bringing these two lines down here. I want to call the insert records function with connection and data as the input, and then my data is going to come from the mock fetch data, which we've imported earlier. So paste that here with the parentheses. Let's save. Let's go into our third terminal and then run the file, and we have data successfully inserted. Let's go to Postgres and let's select star from raw weather data, and here we have that record. So all of these functions work, and let's package everything together. So I'm going to make a function called main, set up my try and except block. I'm going to insert these lines into the try block, and I'm going to do except exception as E and print as an F string an error occurred during execution and pass the E variable. And then after all of this, regardless of whether it succeeded or not, I'm going to do finally if the variable connection is in locals. I want to close the connection and print database connection closed. Let's save this. In Postgres, I want to clear this record by doing truncate table dev.rawweatherdata semicolon. Let's select star again. The record is gone. Let's go to our third terminal and let's go to our insert records file. Let's call the main function and let's run this file. Everything ran successfully. Let's go back to Postgres. Let's select star and we have our record. And so we've completed with all the functions here. So I'm going to delete this line and save this file. Now, how do we automate this so we don't have to manually run the file each time? We're going to use a tool called Airflow. Let's open up a new terminal, and this service I'm going to call AF. I'm going to call this service container as Airflow container. And what about the image? Let's go to Docker Desktop. Let's search for Airflow, and here we have the image as well as the tag. I'm going to use version 3.0.0. So let's go to Docker Compose, and I'm going to type Apache Airflow 3.0.0. Now for the ports, I'm going to bind my local port 8000 with the server's port 8080, which is what Airflow uses. And for the environment variables, I'm going to overwrite Airflow _database _SQL alchemy con with the address of our desired database. I actually want to create a new database just for Airflow so that it can store its metadata over there. I also want to create a new user just for Airflow so that it can have ownership over the new database. So inside the Postgres folder, I'm going to create a new file called airflow init.sql, and it looks like I don't have permission to create that file. So let's check out the permissions of that folder. I'm going to do ls-l and copy the path and enter. And this 999 means the user inside the Postgres container, and all of these dashes means that I don't have any access at all. And so let's add the group write permissions to this directory. I'm going to do sudo changemod -r g+rw and copy the path of this folder. I'm going to type in my password, and now I want to change the group of the directory to my users group. So I'm going to do sudo change group -r user and the directory's path. And then I'm going to make sure the group members can read and write. So sudo change mod -r 770 and the directory's path. So let me hit retry. And now we were able to create this file. So this file is going to contain instructions for Postgres to go ahead and create the user Airflow with password Airflow, and to create the database AirflowDB, making the owner Airflow. Let's save that, go back to Docker Compose, and that allows me to type the address of this database, which is going to be PostgreSQL plus the psychopg2 adapter, // the username and password, Airflow, at the service name, which is DB, on port 5432, / the name of the database that we'd like to access, so Airflow DB. Now, Airflow works off of Python files which contain instructions on what it should automate. These instructions are called DAGs, and we'll be creating these files. So inside the project folder, I'm going to create a new folder called Airflow, and inside of that, create another folder called DAGs. And this is where we're going to save our DAGs. So I'm going to set up volumes because I want the container to recognize this folder and mount Airflow DAGs with the server's OPT Airflow DAGs. And I need a dash right there. Now I want to run the service after Postgres starts. So I'm going to set depends on to DB. I also want Airflow and Postgres to communicate with each other internally. So what I'm going to do is on the same hierarchy as services, I'm going to set networks. And I'm going to create a network called my network. And the driver is going to be bridge. Now I can put Airflow in this network, just like that. And I can also put Postgres in this network as well. Now let's save this. I'm going to clear this terminal. Let's cd into the project folder. And let's run docker compose up. And you can see we're now pulling the Airflow image. It says that the role Airflow does not exist. Let's quit this process. And that's because I need the Postgres container to recognize this SQL file on my local drive. And so I need to set up a new volume for Postgres Airflow init.sql and mount that with docker entry point initdb.d Airflow init.sql. Let's save this and run docker compose up again. And we're getting the same error. So I'm going to kill this process. And this is because we're trying to initialize the database with the SQL command, but the database has already been initialized. So what I'm going to do is check to see if any containers are running, and there are none. Then I'm going to delete my Postgres data folder, which contains all of the previous initialization. So I'm going to do that with sudo rm -rf.postgres data. Okay, we could see it's been deleted. I'm going to do docker compose down and then run docker compose up. And now we created the role and the database, and Airflow's gotten back to us with a command error. And this is because Airflow needs a command to run. So I'm going to set command --c Airflow db migrate and Airflow standalone. Let's save this. Let's kill this process. Let's do docker compose down and then docker compose up. It says database migrating done. And if we wait a few minutes, then it's going to start up Airflow. So let's give it a minute or two. Now we get that Airflow is running. If I search for password, we get Airflow's credentials. So I'm going to copy that and go to this link, open, and it says this site can't be reached. Well, that's because we have Airflow running on port 8000 locally. And so let's go to localhost 8000, and that's going to route us to port 8080 in the server. So let's sign in with the credentials given, and now we're inside Airflow. I want to check something else. Let's open a new terminal so that we can run Postgres. I'm going to cd into the project folder, and I'm going to do docker compose execute db psql the user database user and the database db. Let's do \l, and we see the Airflow database that we just created. So let's change into the Airflow database with \c Airflow db, and then let's check out the schemas with \dn, and we have a public schema. And let's do \dt public.star, and we see that Airflow has saved 45 tables in this database. Let's hit Q to close that window, and we've successfully set up Airflow. Let's go to the DAGs, and we see no DAGs found because we need to create them. So let's go to our DAGs folder and create a new Python file. Hey, it's me from the future. At this step, you might have trouble creating files in the DAG folder. For example, if I do orchestrator.py, then I get a permission error. And so the first thing I'm going to do is check for the current permissions by doing ls -l and copying the path of Airflow. And then I'm going to do sudo change group -r $user and paste the path to Airflow. I'm going to type in my password. Let's inspect the permissions and see how it changes from root to Calvin. Then I'm going to do sudo changemod -r 770 and paste the path and check the permissions. And now I should be able to create the file and create a new Python file called orchestrator.py. Now the base structure of a DAG is pretty straightforward. You start with, from Airflow, import DAG, and then you call the DAG constructor, and it's going to have DAG ID, and let's call this Weather API Orchestrator. It also has default args equal to default args, and it has a schedule. Now we set this constructor equal to DAG, and then we call it down here. With DAG, we have our first task and our second task, and so on. So now where do we get the default args? We create the dictionary up here. We set default args equal to. In curly braces, we have things like the description. So let's say a DAG to orchestrate data. And then we have the start date, which is essentially when we want this DAG to be considered active. So let's say datetime 2025 4:30. And for that to work, I need to do from datetime, import datetime. And also in the default args, we have catch-up, which is essentially, do we want to backfill with previous runs? And I'm going to say false. Now back to the DAG constructor, we have this schedule where we can set how often we want this to run. And so I'm going to do time delta minutes equals 1. And for that to work, I need to import time delta as well. And now how do we define our tasks? Well, I do task 1 is equal to some kind of action. And the thing that does this action is the Python operator. Inside the Python operator, we have a task ID, and let's call it example task. And then we have a Python callable, which calls the function that we want to run. So for example, if I have a function called example task, and this is going to print, this is an example task, then what I want to call here is example task. Now for the Python operator to work, I need to import from Airflow operators Python. I'm going to import Python operator. Let's save this. Let's find our Docker terminal, kill this process. So my DAG keeps disappearing on me. If I look at the logs, it says killing the process here for DAG file, and then the process exits. I wonder if it's because of this line right here. Let me wrap this in a function, call it safe main callable, and indent this, and then return the main function, and replace the Python callable with safe main callable. Save that. Let's kill this process and do docker compose down. Let's do docker compose down -v, and then let's do docker compose up. Let's refresh Airflow, and let's pick up our new credentials and sign in. And here's our DAG again. Let's click on that. I want to check our latest run. Everything looks okay. Let's go to the code, and this ran with our new function. Let's go to Airflow, refresh, and we see we have our DAG here. Let's click on this DAG. Let me resize the panels. I'm going to unpause this DAG and hit refresh, and our first task ran successfully. So if I go to the grid and I click on the latest run and then go to the task ID, then I could see the logs and I could see our print statement. This is an example task. So now we want to call the main function from the insert records file. I want to do something like from insert records import main. But we have to think, we're technically in the container, because in the Docker Compose file, we told Airflow to use the DAGs folder as if it lives in the container. And so our DAG, which lives inside the container, is unable to access any of the files that exist outside of the container. So in the volumes, I'm going to add API request, opt, Airflow, API request. That way the Airflow container can treat our API request folder as if it exists inside the container. And I'm going to allow Airflow to have access to insert records by appending the API request folder into the system path. So I'm going to do sys path append opt Airflow API request. And then I can delete the example task function, and I can replace example task with the main function. Let's save this and go back to Airflow. I'm going to click on DAGs. Now I have an error here. Let's check it out. It says sys is not defined. Did you forget to import sys? Yes, I did. So in my orchestrator file, I'm going to import sys. Let's save that. Go back to Airflow. Let's refresh. we have another error, and this one says no module named insert records. Well, just a moment ago, when we made edits to our Docker Compose file, we were supposed to stop the containers and run them again. So I'm going to kill this process, and I'm going to do Docker Compose down, and then Docker Compose up. Now let's give it a minute, and Airflow is running now with new credentials. So I'm going to copy this password, go back to Airflow, refresh, and sign in. So it looks like we're having some trouble detecting our DAGs. I'm going to open a new terminal, cd into our project folder, and run docker execute -it airflow container bash. And now we're inside the Airflow container. I'm going to do ls opt airflow dags, and I get permission denied. So I'm going to need to update the permissions again. Let's open a new terminal. I'm going to do ls -l and copy the path. And I'm going to do sudo change owner -r $user airflow dags, enter my password. And this is because we need to cd into the project folder. And let's try the change owner again. Let's see the new permissions now. So that hasn't changed. Now let's sudo change mod -r 755 airflow dags and check the permissions again. And now we have execute permissions. Let's go back to our Docker terminal. Let's kill this process. Let's do Docker Compose down and then Docker Compose up. And let's get our new credentials, go back to Airflow, sign in, and now we should see our DAG. And now we don't have errors. So let's go to the orchestrator and let's take a look at the latest run. And it's still example task. Let's see why. That's because I didn't update my task ID. So let me change this to ingest data task, save this. Let's go back to Airflow. I'm going to refresh and I'm going to trigger this DAG. And now we can see we have the ingest data task here. Let's click on the latest run and the task ID. And we actually see that the database connection failed. It couldn't connect to port 5000. That's because if we go to Docker Compose, port 5000 is in our local machine, but within Docker, we want Airflow to communicate with the Postgres container, which lives on port 5432. So let's go to insert records and let's change the host to the service name DB, and let's change the port to 5432. Let's save this, go back to Airflow, let's refresh, let's trigger this DAG, and let's click on the latest run and the task, and now we see that the data was inserted successfully. Now let's go to our Postgres terminal. I'm going to run Postgres, and then I'm going to do select star from dev.raw weather data, and here I see new records, and so we've successfully set up this DAG for our API request. So I see new records were inserted. Now I want to try this with live data. And so up here, you notice that I brought in fetch data from the API request, and then scrolling down, I commented out mock fetch data, and I started calling the actual fetch data from the API. So when you do that, we can go to Orchestrator, and we could set our schedule to every 5 minutes, and that's because it seems that the weather is updated every 5 minutes. So let's save that, and then once you make those changes, then you can go back to Airflow and let it continue to run on schedule. Here we could see we collected a few more data points, and so I'm ready to pause this DAG. Hey, it's me from the future. At this stage, I don't recommend taking more than 2 data points because there's going to be something we do later on where we have to wipe our data. Let's kill this process. Now I want to be able to transform the data for analytics and reporting. For that, I'm going to use a tool called dbt. In Docker Compose, I'm going to search for dbt, and let's take a look at the first one. It seems like this image is not compatible with Postgres. So let's check out the next one by Fishtown Analytics. And it looks like this one's deprecated, but the newer images can be found in these locations. So I'm going to click on the link for dbt Postgres, and here we can find the image and the tag. So let's set up the service called dbt, and the container name is going to be dbt container, and the image is going to be what we found on GitHub. And for the volumes, I want Docker to create my dbt folder and mount that to its user app folder. And then for the working directory, I'm going to use the user app folder, and I want the service to depend on Postgres running, and I want to put this in my network. And for command, let's start with init and call our project my project. Let's save, and then I'm going to do Docker Compose down, and it says network is not allowed. That's a typo, so I'm going to make this plural, Let's try Docker Compose down. And to set up dbt, I'm going to do Docker Compose run dbt. This will allow us to interact with its terminal, and it's asking which database would you like to use. I'm going to select one for Postgres. The host is going to be DB, port is 5432, the user is DB user, the password is DB password, the database name is DB, and the schema is dev. And these are all the things that we've determined in the Postgres container here, as well as in the insert records file here. And for threads, I'm going to do 4. It says our profile was written to this directory, and now we have to run dbt debug. So I'm going to replace this command with debug. Let's do Docker Compose down, and then let's do Docker Compose run dbt. Now it says dbt could not find these two files. The dbt project file lives inside the dbt folder and inside my project. So what I can do now is revise my volume so that the my project folder is mounted with the user app folder. Let's save this. Let's do Docker Compose down and then Docker Compose up. And now dbt was able to find the dbt project file. Now we want to locate the profiles.yaml file. I'm going to try to overwrite the environment variable called dbt profiles directory, and I'm going to set this equal to this parent directory here. Let me save, kill this process, do Docker Compose down, and then Docker Compose up, and that didn't work. So what I need to do is I need to find the profiles YAML file in the container and bring it out to my local. So let's kill this process. I'm going to do docker ps-a to see a list of all of my containers, and the container that has my profile.yaml file is the one with the dbt init command. So that's this container. So I'm going to do docker cp, which is copy, from this container ID, :/root/dbt/profile.yaml. I want to copy this into my dbt folder, so I'm going to take the path and paste it here and enter. I made a typo. It's supposed to be root and then .dbt. So let's enter that. And there's another typo with profile. It's supposed to be profiles with an S. And let's enter. And then now I get permission denied. So let's modify the permissions here. I'm going to open a new terminal. And similar with what we did to the Postgres folder, I'm going to check the permissions of the dbt folder with ls-l and the path. Then I'm going to do sudo change group -r $user and paste that path. I'm going to type in my password, and then I'm going to do sudo change mod -r 770 and paste that path. Enter. Let's go ahead and try to copy over the profiles.yaml file. And now we see we've successfully copied the file over. So now I'm going to do Docker Compose down and then Docker Compose up, and it still can't be found. Well, that's because I need to add to my volumes. So I'm going to kill this process, and I'm going to mount my dbt folder to the server's root and .dbt. Let's save that. Let's do Docker Compose down and then Docker Compose up again. And now it says all checks passed. Now I'm going to kill this process again. And the last thing I'm going to do is I'm going to replace the command with run, because if we look at the models folder, we have some example models that we can build. And so we'll be able to build those with the run command. So let's do Docker Compose down and then Docker Compose up. And now you can see our models were built successfully. I'm going to keep this terminal running, and I'm going to open a new terminal so that I can access Postgres. And so I'm going to cd into the project folder, and I'm going to do Docker Compose execute db psql user db user and database db. And if I do \dt dev.star, then you could see this table, which came from this model. Now I want to start creating my models, so I'm going to delete this table with drop table dev.myFirstDBT model. And it says I can't drop this because it depends on my second DBT model. So at the end of this line, I'm going to say cascade and enter. So if I do \dv, which is a view or like a different type of table, and then I do dev.star, and that confirms we've also deleted my second DBT model, which was a view. And just to be sure, you could do \dt dev.star and we don't have any more tables. Now I'm going to delete the example folder and all the content inside, and then I'm going to go to dbt project and delete example and its configurations, like that, and save. Hey, this is me from the future. All I did was just exit out of all of my tabs so that I could work off of a clean slate. And if you want, you could do the same and just keep going on. The first thing I'm going to do is declare my sources. So inside my models folder, I'm going to create a new folder called sources. And then inside that, I'm going to create a file called sources.yml. And I'm going to do version 2, sources, the name of the schema, which is dev, the database, which is db, and the tables. So we have one with the name raw weather data, and it has columns with the following names: ID, city, temperature, weather descriptions, wind speed, time, inserted at, and UTC offset. Let's save this. Now I want to create my staging layer. So inside the models folder, I'm going to create a new folder called staging. It's still under sources, so I'm going to drag this to models, move, and inside the staging folder, I'm going to create a file called staging.sql, and I'm going to start with a config block with double curly braces, config, parentheses. I want this materialized as a table, comma, and the unique key is going to be ID, and I'm going to do select star from double curly braces, source, parentheses, dev schema, raw weather data table. Let me save this. I'm going to open a terminal, and I want to run dbt so that I can create this table. So I'm going to cd into weather data project. I'm going to refresh the Docker group. I'm going to do docker compose up dbt. I'm getting this message because my Docker desktop closed on me. So I'm going to open that up, and I'm going to make sure it's still integrated with WSL settings, resource WSL integration, and it's enabled. So let's go back. I'm going to run docker compose up dbt, and it successfully created the staging model. So I'm going to open a new terminal, cd into the weather data project, refresh the Docker group, and let's open up Postgres with docker compose, execute db, and the Postgres command psql user db user, and the database db. Let me do /dt dev.star. We have our staging table, and let me do select star dev.staging semicolon. I forgot the from clause. Let's try that again. And we've successfully created the staging table, which means that we've correctly declared our source. So let me actually stage this. I'm going to say with source as this query, format that. I want to select ID, city, temperature, weather descriptions, wind speed. I want to rename time as weather time local, and then I want inserted converted to local time. So I'm going to do that by inserted at plus UTC offset, which is the next column, setting this as hours, and then : interval as inserted at local. And this is all from the source. Save this. Let me go back to my dbt terminal. I'm going to docker compose up dbt. This ran successfully. I'm going to go back to Postgres. Let me hit Q, and then let's do select star from staging. And we could see that these changes have been made. I'm going to create one more folder in models. Let's call this mart, and create a new file called weatherreport.sql. And this is the layer where we create tables that we intend to turn into reports. So I'm going to set up my config block with the double curly braces, config, parentheses. I want this materialized as a table. The unique key is going to be ID. And I could do select star from double curly braces. I'm going to reference the staging model. Let's save. Actually, let's go by naming conventions. So I'm going to turn staging.sql to stg weather data, and then change the staging reference to stg weather data, and save. I realize I have some duplicate data in the first 3 rows, so I want to go back to the staging model and see if we can deduplicate here. So I'm creating another CTE. I'm going to put a comma here. I'm going to call this dedupe as select star. I'm going to give a row number to each time frame's record over partition by time, which is what this column is originally called, and order by inserted at, which is what this column was originally called. And I'm going to call this as RN, and this is going to be from source. Let me comment this out, and I'm going to do select star from dedupe. Let's save. Let's go to the dbt terminal. I'm going to do docker compose up dbt. The models got created. So I'm going to go to Postgres. Let's hit Q. I'm going to select from staging. Actually, we did change the table name, right? So I'm actually just going to do select star from stage weather data, semicolon. Of course, I need the schema, dev. And now we see that for each time frame right here, we have row numbers 1, 2, and 3. And I think it would make sense to get the earliest record just for our use case. And so I'm going to do where rn equals 1. I'm actually going to uncomment this, change the source to dedupe, apply my filter here, remove these lines, save, and then let's go back to Postgres, hit Q. Let's take a look at the tables with dt, dev.star. I'm going to drop table dev.staging, semicolon, and I'm also going to drop table dev.stage weather data, semicolon, and let's go to dbt and docker compose up again. It ran successfully. Now let's select star from stage weather data, and you see we got rid of the duplicate records. Let's go to weather report. Perhaps we don't need the record ID, so I'm going to delete select star, and I'm just going to do city, temperature, weather description, wind speed, weather time local, and maybe I don't need the inserted at local as well. I'm going to create one more table inside Mart and call this daily average.sql. Hey, it's me from the future. Here I'm going to give a recap because there was a portion that I did not record. So I created this daily average model. Notice it doesn't have a unique ID, so I deleted that. And sourcing from the stage weather data model, I get the city and the weather time local, and I wrap that in date to get the day of the record, since I want to get the daily average. Then I took the average of the temperature and the average of the wind speed, grouping by the city and the date. And the average gave me a bunch of trailing decimals, and so I wrapped that in round, 2, but came across a data type issue. So I had to convert double precision to numeric for the round to work. And then when I get more data points in the future, I can order by the city and the date. And I ran the dbt models, everything ran successfully, and I went to Postgres, went into staging, saw that I took care of the duplicate records, and then did select star from the daily average, and got the result that I expected. So I finished creating all of my models. Now let's talk about creating a DAG for dbt. I'm going to copy the orchestrator file and call it dbt orchestrator. I can delete these two lines, and I'm going to call this weather dbt orchestrator, and let's call this task 2. And what we want to do is trigger the dbt container. So instead of Python operator, we're dealing with a Docker operator. So I actually want from airflow.providers.docker.operators.docker import Docker operator. And I'm going to set task 2 equal to Docker operator, and its parameters are going to be task ID, the image, the command, the working directory, mount, which are the volumes, the network mode, the Docker URL, and auto remove. For task ID, let's call this transform data task. The image we're going to get from Docker Compose, and I'm going to copy this and paste it here. The command we're also going to get from Docker Compose. It's going to be run, so paste it here. The working directory, also from Docker Compose, paste that there. The mount are going to be our volumes, so let me copy this and just paste it down here for our reference. And we're going to use one mount constructor for each volume. So I call mount, which is going to take in source, target, and type. I'm going to put a comma here, and then I'm going to copy this again for the other volume. For the source, it only takes the absolute path. So let's look for dbt my project, which is right here. I'm going to right click and copy the path and paste it in source, and the target I'm going to take from the volume mounting right here and paste that, and the type is going to be bind. And then for the other mount, I'm going to look for my dbt folder, which is right here. I'm going to right click, copy path, paste it as source, and then the target I'm going to take from the mounting and cut and paste. And then the type is going to be bind. Now I could remove my notes. And then for the network mode, I'm going to take that from the Docker Compose. It's my network, and paste that here. And the Docker URL is going to be unix://var run and docker.sock. And this is the path to the Docker socket. And auto remove is going to be success. Now going back to the mount, this only works if I import it from docker. types, import mount. Let's save this, and let's do docker compose up. Let's take a look at the logs. It says configuration paths exist in your dbt project.yaml file, which do not apply to any resources. It still references example. So let me go there, dbt project. I can scroll down, and I could actually just delete these 2 lines and save that. It looks like our dbt models ran successfully, and we got a new password for Airflow. So I'm going to copy this, and let's go to this link, open. It says site can't be reached because, well, if you look at the docker compose, we have to go to our local port 8000, which then gets routed into Docker's port 8080. So let's change this to 8000, and I'm going to input my credentials and sign in. Let's go to DAGs. Looks like we have an error. Let's check it out. It says perhaps you forgot a comma in line 38. So let's go to dbt orchestrator, line 38, and I did forget a bunch of commas right here and here. So let's save that and go back to Airflow. Let's refresh. I get another error. Let's check this one out. It says the name Python operator is not defined. Let's go back to dbt orchestrator, and that's because we're not using this anymore. So I can delete this block. Let's save. Go back to Airflow, refresh. Let's check out this new error. It says invalid arguments were passed to Docker operator, this task ID. So let's go to the dbt orchestrator file. Looks like I missed in the second mount, profiles.yaml, and in the target as well, profiles.yaml. And also, mount should be lowercase m. Let's save this, go back to Airflow, refresh, and we have no errors. Now let's go to Weather dbt orchestrator. Let's unpause the DAG and refresh. And it looks like we have a failed run. So let's click on our latest and click on task ID. And it looks like Airflow's unable to access Docker. So let's go to Docker Compose. And in the Airflow volume, I need to mount my system's var run docker sock with Airflow's var run docker sock. Let's save this, go back to Airflow, refresh, and let's trigger a new run trigger. Let's check out the latest, click on task ID. I still get the same error, so let's go to VSC. Let's open a new terminal. Let me just check the socket with ls-l var run docker.sock. So that's working fine. Let's go back to the Docker terminal, and let's quit this process with Control-C. And let's try docker compose up -- build. Let's give it a few minutes, and it gives me new credentials. So let's go back to Airflow and refresh. I'm going to sign in again. Let's click on DAGs and go to the dbt orchestrator. Let's trigger this again. Let's click on the latest and the task ID. We're actually getting permission denied. Let's quit this process. I want to check the group ID of the Docker socket with stat -c, single quote, %g, single quote, /var run docker.sock. And it's in group 1001. Then let me do group _add 1001. Save. Let me do docker compose up. Let's give it a few minutes. We got new credentials. Let's go back to Airflow, refresh, sign in again, click on DAGs and dbt orchestrator and refresh. And let's trigger a new run. Let's click on the latest and task ID. And it says failed to set up container networking. My network is not found. I think what's happening is our network called my network is what allows dbt, Airflow, and Postgres to communicate with each other. But if we look at dbt orchestrator, we have Docker operator spin up a new dbt image, which is separate from the dbt image in our Docker compose file. So we need to somehow get the new containers to communicate using our network. Let me quit this process. Let's check out the networks that we have. If I do docker networks ls, it should actually be singular. We see that even though we named our networks my network, Docker compose adds this prefix to the name. So every time Docker operator spins up a new container for dbt, it's trying to look for my network, but that's not one of the networks that are available. So I actually have to replace my network with weather data project _ my network. Let's save that. Let's go back to Airflow, refresh. Let's do docker compose up, and we got new credentials, and it's not giving me new credentials. It says it has been previously generated, but let me try going to Airflow and refresh, and I'm still logged in, and it looks like it ran the job successfully. Let's click on the latest task, transform data task, and we have logs that say our dbt models were created successfully. So now we have dbt running on a scheduler. Now the last thing I'm going to do is I'm going to set up my DAG so that dbt runs after the API data has been ingested successfully. So in this segment, I'm going to move the content from dbt orchestrator into the orchestrator file. So I need to bring the Docker operator and the mount. The default args and the DAG is the same, and I'm going to bring task number 2 and bring it under task number 1. I can remove this comment, and at the end of my with block, I'm just going to do task 1 is greater than task 2, and this sets the dependencies. And then I'm going to remove my dbt orchestrator file. I'm going to go into Airflow, refresh. Let's click on this orchestrator. Let's click on the graph. And here we see our 2 tasks. Let me go back to orchestrator. I'm going to change the DAG name, API dbt orchestrator. Let's have this run every 1 minute. Save. Let's go back to Airflow, refresh. Click on the new DAG, unpause, refresh. Let's click on the latest run, and it successfully completed the 2 tasks. Let's refresh again, and it finished running our second task. So with that, I'm going to pause this DAG. Now let's bring in the tool that's going to help us visualize the data. This tool is called Superset, and a lot of tutorials say to clone the repository, but this is a massive repository. We just need a few files. So first, let me go to my terminal and do docker compose down, and let's also do docker compose down -v, and let me just put these windows side to side. So the first place I'm going to go to is if we scroll down, we see docker compose. So let me click on that. And here we see a bunch of services. We don't need all of them. I'm going to copy over Superset. I'm also going to copy over Superset init. And I'm going to copy over Redis. And then let's go back. I'm going to go into the Docker folder. And in my own project, I'm going to create a new folder called Docker. And I want to bring in the content of some of this file over. So we're going to start with the Docker init. And in my Docker folder, I'm going to create a new file called docker init.sh. Make sure the name's exactly the same, and I'm going to copy the contents and paste it into my file and save. Let's go back. The next thing I want is Docker Bootstrap. So I'm going to create a new file called Docker Bootstrap, and let's open this, copy the contents, and paste. Let's go back. Next, I want the env file, so .env. Let's open this up, copy the contents, and paste. And then let's go back, and I want to go into Python path _dev. And in my Docker folder, I'm going to create a new file called superset_config.py and bring in the contents of the corresponding file, copy, and paste. Now let's go to our Docker Compose. And if we look at Superset init, then it's going to have us build a custom Docker image, which we're not going to do. So I'm going to delete that and replace that with image. And the image I'm going to use is Apache/Superset: 3.0.0-py310, because this version will contain some of the Python packages that we'll need. Now looking at the env file, I just need the top one. So I'm going to delete these 2 lines. And looking at the user and the volumes, we have some variables. So if we go back to Superset's Docker Compose file, we see that they've defined their variables up here. So I'm going to copy over both and paste them on top of services. Now looking at the volumes, we don't need all of these. We don't need Superset front end, we don't need Superset home, and we don't need tests. But what we do need is to mount the Superset config file so that Superset can recognize it. So I'm going to mount docker superset config.py and mount that to app python path superset config.py. Let's scroll down. For the environment variables, I don't need Cypress config, and I see that the Superset load examples comes from the .env file. So let's go to .env. Let me open this in a split window, and I'm going to bring over Superset config. So ultimately, we're trying to create this database URI, and it has the database dialect, which uses this. And here I want to add the psychopg2 connector. The database user is going to be Superset. The database password is also going to be Superset. So this tells me that in Postgres, I have to create another user. The database host is going to be DB, which matches our Postgres service. The database port is 5432, and the database DB is going to be Superset. Now for the examples URI, our database dialect is going to be the same. The examples user is going to be examples. The examples password is going to be examples. The host and the port are the same, and examples DB is going to use the database examples. So I'm going to go into my Postgres folder, and I'm going to create a file called supersetinit.sql, and I'm going to copy over the code from Airflow init into this file, and I'm going to create the user Superset with the password Superset, I actually want my database to be called Superset DB and the owner as Superset. Let's go back to .env, and I actually want to change the database DB name, but it says do not modify. So I'm going to try to work around this and call the Postgres database as Superset DB. Then I'm going to go back to Superset init, and I'm going to duplicate this code and create user example with a password example and create the database example DB with the owner as example. Let's go back to Docker Compose and back to Superset init. I'm going to overwrite the environment variable database DB, which is this value here, as the value that comes from Postgres DB. And that way, instead of Superset, it's going to be Superset DB. And the last thing for Superset init is that I'm going to include it into my network. Now let's look at Superset. For the environment file, it's just going to need the top one. And for the build, we're just going to replace this with the image that we used above for Superset init. The port is going to be 8080, so I don't need the bottom one. I don't need the extra hosts. For the environment variables, I don't need Cypress config, and I'm also going to bring in the database DB. But I realize that there should be an underscore, so I'm going to fix that, and then let's copy that over. And lastly, let's copy over this network so that we include Superset into our network. Now for Redis, everything looks good. I see that it creates a Docker volume, which is going to be stored in the Docker server as opposed to local. And so I'm going to create the volumes, Redis, and external false. Let's save that. And another thing we have to do is we have to go to the Postgres service and we have to mount this new file that we created. So I'm going to mount Postgres superset init.sql with the Docker entry point initdb.d/superset init.sql. Now, before I run Docker Compose, I have to remind myself that these SQL commands will only be executed at the initialization of Postgres. We already initialized Postgres, and all of its metadata is stored in data. But also knowing that we have some API data stored inside this folder, we're going to make the executive decision to remove that data for the purpose of integrating Superset. So I'm going to do Docker Compose down. I'm going to do Docker Compose down -v. That's a typo. -v. Let me do sudo rm -rf /postgres data. I'm going to type in my password, and I've deleted the data folder, and then I'm going to do Docker Compose up. It says we got permission denied trying to access the Docker init file. So let me check the permissions of Docker. I'm going to copy this path, and I'm going to do ls -l and the Docker path. And what I want to do is sudo change group -r $user and paste this path. Let's check out the permissions. Nothing's changed. And I'm going to do sudo change mod -r 770 and paste this path. Now let's check the permissions. And here we have read, write, and execute. So let me delete the data folder again. Let me do Docker Compose down -v. And now let me do Docker Compose up. It looks like we got an error at superset init. Let me remove the superset volume. And I'm going to do Docker Compose down -v. And then I'm going to remove the superset folder with sudo rm -rf /superset. I'm going to remove the data folder again, sudo rm -rf /postgres/data. And let's try Docker Compose up. And it looks like we got another error with superset init. It says that the database superset does not exist. And let's see where this comes from. Well, in the superset init file, we want to create the database superset DB. In the Docker Compose, we wanted our database DB to be the value of Postgres DB. Postgres DB is Superset DB, and it seems like Superset is not recognizing that. Let's go to Superset config, and here I want to debug the environment variables. So I'm going to say Superset environment debug. I'm going to print the database dialect. I'm going to print the database user, and the database host, and the database DB. I've added this code block here so that we can print some of these values. Let's save. Let's do Docker Compose down -v. Let's remove the Postgres data folder, and let's do Docker Compose up. So here everything else prints except database DB, which is just a blank string. So that means something's wrong with this environmental variable. I'm going to go to Docker Compose and simply overwrite the database DB variable as superset _DB for both the superset init and superset services. Let's do Docker Compose up. And now it looks like we get a different kind of error. It started loading the examples, but it says password authentication failed for user examples. But Postgres says the role examples does not exist. Let's first check the superset init SQL file. And here we have it as singular, So I want to put an S at the end to the user, password, the database, and the owner. Let's go to the .env file and make sure that examples is plural. Now let's try this again with docker compose down -v and remove the Postgres data folder and then do docker compose up. Looks like we're starting to load the example data, so let's give this a few minutes. Now it looks like Superset init loaded some example tables and then ran into an error for too many requests. And that's okay for now because we were able to get a few examples. And let's go back to docker compose. And for Superset load examples, let's replace this with no. I'm going to do docker compose down to stop the containers. And this time, we don't need to remove the Postgres data folder because we saw that Superset was able to establish a connection with Postgres and save some data into it. So I'm just going to skip right to docker compose up. And now we're running the Superset app. Now it says that Superset is running on 8088. So I'm going to click on this link and we get an error connecting to Redis. So let's go back to docker compose. And I see that Redis is missing from my network. So I'm going to add it to my network. Let me kill this process. And I'm going to do docker compose up. And let's return to this link. And we're now in Superset. On the dashboard, you could see some of the examples. Let's click on birth names. And we see it looks like that. And now I want to see my data. So in settings, let's go to database connections. And here we're connected to examples. But I want to bring in the DB database. So let's click on add database. Postgres, the host is DB, port is 5432, the database name is DB, the username is DB user, the password is DB password, the display name, I'm going to call it DB, and connect. And it says database connected, so let's finish. Now let's click on datasets and add dataset, and let's go to database, click on DB, the schema is dev, let's check out the dev schema. And currently we have no tables because we deleted the Postgres data folder as we were trying to connect to Superset. Let's go back to the terminal, and here we have credentials for Airflow, and I can't find my new Airflow credentials in the terminal. It says that the password has been previously generated, so maybe I just have to go to localhost 8000. Going to localhost 8000 still asks me to sign in, so I'm going to open a new terminal, cd into my weather data project, and let me do docker ps to see what's running, and let me do docker compose down, the service name for Airflow, and I'm going to docker compose up, just Airflow. Let's give this a minute, and here we can get our new credentials. So I'm going to sign into Airflow, let's click on DAGs, and let's go to our orchestrator. I'm going to unpause this DAG and refresh, and we see that it completed its first run, and the next one is in 5 minutes. Now I can go back to Superset and refresh the table, and we see that our tables were created. Now for this version of the recording, I don't know how my weather report model went missing. So as a proxy, let's just use stage weather data for now. And using this table, I can create a data set and create a chart. The chart I want to use is scatterplot and create chart. Now I can drag my columns like weather time local to the x-axis, and I can drag temperature to metrics, and my aggregation is going to be the sum, which is within the time grain. So let's save this. Let's adjust my time grain to minute. And then I can also drag my wind speed into metrics. And maybe I want to take the average of this and save. Now let's create chart. And then I can go ahead and save this and call the chart name weather report and save. And then I can go into dashboards and create a new dashboard and either create a new chart or select one of the charts that I already have. So let's drag this here. I can name my dashboard as something like weather dashboard, and let's click on more options and edit property and set auto refresh interval. And I could set my refresh frequency to as often as every 10 seconds to get essentially real-time data. But since our Airflow DAG is running every 5 minutes, I just need to refresh this every 5 minutes. So let's save and then save this dashboard, and we've created our chart. And this is how we can visualize our data. Let's go back to the terminal and kill this process and clear the terminal, and so we have everything set up, which means all I need to do to run all of these tools is just simply docker compose up and sign in to the respective applications.